Hello, everyone. Good morning, good evening to everyone there. I hope you are all doing good. Okay, so let's get started with today's webinar. And the topic of today's webinar is decision tree, where I will try to give you various insights on how to build a decision tree and how can we do it as a classification algorithm. So let's get started with decision tree algorithm. So we will start with what is classification all about. Then we will go into, what are the types of classification we have. Then we will go into classification use cases. What is a decision tree, right? And what are the terminologies which are used in associated with decision tree, visualizing a decision tree and hands-on expertise on a decision tree. So first of all, let's start with classification. So what is classification? And if I have to tell you about classification, uh, like for example, what happens is like we have two type of when we talk about machine learning is nothing but like a series of instructions you give it to the computer so that it can learn the patterns from your data set, right? To give you an example, imagine that there is a trending topic. For example, you want to find it out whether Prime Minister Modi will be the second prime minister, once again the prime minister for the country or not. Okay, so now what you will do is you will collect the data set from multiple different sources, and you will actually build it like a algorithm where you will get a label as yes or no. Yes, he will continue as the next prime minister, or no, he will not continue as a next prime minister. So you will collect the data set and you will feed this data set to the computer, and this process is called as a machine learning, right? So now in this case what happens is so this is about the classification, right? So now machine learning is basically of two types. One is called as a supervised machine learning, another is called as a unsupervised machine learning, and the third one is a reinforcement machine learning. So when we speak about supervised machine learning, as the name suggests, it provides some supervision, right? For example, the teacher teaching the kid, it's a supervised machine learning, right? So we will give the trained examples, we will give the trained data set with the pure label on top of that. This is called as a supervised machine learning. So if I draw in front of you, this type of machine learning look like this, supervised machine learning, where what happens is like you would have the data set, which is a structured data set, and you would have one column which is called as a label, what you want to predict. Okay, and you would have a various predictors by which you want to predict. To give you an example, imagine that you want to predict a pricing of a community. Okay, you want to predict what would be the pricing of apartment in a particular community, right? Now these can be the variable, like you can see that what would be the number of how many floors it has. You can have a variable like what is a pollution level, how many educational institutions are nearby, right? So based upon that the pricing will change. But this type of supervised machine learning, why it is called supervised machine learning? Because we provide the independent variable, or we provide the predictors, also we provide the label data set. Okay, now this supervised machine learning is basically of two type. So this supervised machine learning, one first is called as the regression based supervised machine learning. Okay, and the second one is called as a classification based supervised machine learning. Now what is the difference between regression based and a classification based supervised machine learning? Regression based supervised machine learning is that machine learning where what you want to predict is continuous in nature. Okay, imagine the you want to predict the community prices, right, which is a continuous value. If it is a continuous value, then we will go ahead with regression based supervised machine learning. Okay, whereas if you want to predict something which is the discrete outcome, to give you an example, you want to predict that whether I will win the match or not. Okay, I want to predict whether the particular employee will churn out from the company or not. You want to predict like whether the person will have a cancer or not. You're getting my point, right? So if you have the output which you want to predict is in the form of yes or no or true or false, right? This is called as the supervised machine learning, but a classification based supervised machine learning. Okay, so classifications based supervised machine learning is the process of dividing the data set into different categories or group by adding a label. Okay, so always remember that whenever you guys want to predict the classes in the data set, whenever you want to predict, like whether this will happen or not, whether a person will do a credit card fraud or not. You're getting my point, right? Whether the employee will churn out from the company or not, right? Whether the particular person will have a diabetes as a disease or not. All these questions, wherever you want to find it out, yes or no, or true or false, or you want to predict classes in the data set, this is called as a classification based supervised machine learning. Okay, so this is what is called as a classification based supervised machine learning. And today I will teach you, I will tell you about various form of classification based supervised machine learning, although we will do a deep dive into decision tree. Right now you will be able to understand that decision tree, how decision tree is connected to the network, what we are learning today with classification based supervised machine learning. Okay, so now we have various algorithms. Algorithm is nothing but a set of mathematical equations for classification based supervised machine learning. We first of all we have something called as decision tree, then we would have something called as random forest, then knife base, and then knn, which is called as a k nearest neighbors. Okay, so let me give you few statements about this algorithm, and we have many others, but today we will focus on one of them, which is decision tree. So now first let's start with decision tree. Now what is a decision tree? What I was telling you is, believe me or not, decision tree is something you use every day in your daily life. For example, you take decisions, and today also you took a decision to attend this webinar, right? But how do you decide a decision? Based on various further decisions, right? For example, for today joining the webinar, you have seen that, okay, when this webinar is about, okay, so you said it is weekday or weekend, then you might have said check it out, right? What is the time of the webinar? Then you might have checked it out, what is the topic of the webinar, right? So, and who is conducting this webinar? So based upon this you took a decision, shall I go ahead or not go ahead? You're getting my point, right? So this is what is called as a decision tree. We call it as decision tree because it is a graphical representation of all the possible solution to a decision. It's like a tree. Like, decision tree is like a tree. Why? Because a tree also start with a root and then it emerge into various branches. Similarly, you have a decision tree, which I'm showing to you here as a simplest algorithm, which is being used for machine learning purposes. Now it is something like this. Imagine that you want to find it out that, like, do you want to go to a restaurant or do you want to buy an hamburger? Okay, so you have two choices. Either you can go for a restaurant or either you can buy a hamburger. Now how would you decide which one you would follow? So you will start with what is called as a root node. You will start with a root node that whether I am hungry or not, right? If I am hungry, right, then only I will go for all these activity. If I am not hungry at all, then simply go and sleep. You got my point, right? So this is how you will start with the first node, which is to find it out whether I'm feeling hungry or not. If I'm feeling hungry, then I will decide that, well, I have money which is around $25 worth. If I have money, then I will go for a restaurant. If I don't have a money, then I will buy an hamburger. You understood this? This is simplest representation of decision tree. Basically, you decide something on the basis of the previous outcomes. And you can imagine any sort of example here. Imagine that you want to find it out whether the person will do a credit card fraud or not. Again, it will depend upon the previous circumstances that, for example, it will depend upon how much is the salary of the person. It will depend upon what is the job profile of the person. It will depend upon the fact that, like, for example, how many fraud or how many cards this person have, right? So on basis of, you will decide that whether this will do a credit card fraud or not. So this is the simplest form of classification based algorithm. Then we have the next algorithm, which is called as a random forest. Now, what is a random forest? As the name suggests, you built one decision tree in the last example, right? But one decision tree can sometimes be overfitting as a case, right? So people said that, like, why should I only trust one decision tree? For example, whenever you take a bold decision in your life, you don't trust only a single voice, right? You want to hear it from multiple different people to make your decision more stronger, right? go to a doctor. If the doctor says to you that you have this type of a disease, you don't believe in that. What you do is you also talk to second doctor, third doctor, fourth doctor to confirm that this is true or not. Okay, so this is what is called as a random forest. As the name suggests, why it is called random forest? It is called random forest because now you're building the various number of decision trees here. It's like a forest of all the trees, right? It is no longer a single tree, it is a forest of complete trees. So for example, you can imagine that if it is my training data set, I will split my training data set into multiple examples, multiple decision trees will be built, and then based upon the majority, I will decide whether should I do this or not. Okay, so it is also called as a bagging sort of methodology where we bring the outcome of various models, or we bring the outcome of various trees all together the to make our powerful decision. Okay, so this is another example, this is another algorithm which is called as a random forest. Then after random forest, we have something called as naive bayes. Okay, now what is a naive bayes algorithm? Naive bayes is also a simplest algorithm, but naive bayes is basically based on the Bayes theorem. Okay, so this algorithm is basically based on the Bayes theorem, and Bayes theorem is based on the conditional probability, right? So it is based on the conditional probability, which is your naive bayes. Now in naive bayes, what happens is like we decide that whether something will happen or not on the basis of probability. So let me illustrate you with this example. Imagine that you want to find it out whether I would have a disease or not. Okay, so first of all, the probability of having a disease is 0.10, and the probability of not having a disease is 0.90. Okay, so if there is a probability of having a disease is 0.10, you will further find it out that what is the probability that my test will be positive given I am diseased. What is the probability that my test to diagnose the disease is negative given I have a disease? Right? Similarly, if you go into this direction, if there is a probability of not having a disease is 0.90, you will find it out that what is the probability of having a disease, test being positive with no disease, and what is the probability of no disease given I don't have the disease, which is 0.90. So basically here you check the outcomes. Here you check the outcome of all the possible combinations. This is what is called as the naive bayes algorithm, or Bayes theorem, or conditional probability based theorem. Okay, then we also have something which is called as a key nearest neighbor, which is the one of the finest algorithm, which also helps you in deciding the classification, right? Now, what is k nearest neighbor? K nearest neighbor, as the name suggests, what happens in this case is we try to build, basically it's like a neighbor. So it's something like this, like if I give you the data set, say I give you the customer data set, okay, and it is a transaction data set. So customer number one has bought a product number one, right, from a particular vendor at a particular rate, and this is a profit this customer has given to us, and this is the revenues. Okay, this is my customer number one. Similarly, you would have customer number two, customer number three, customer number four, right? Now if I ask you that which customer profiling is nearby same, right? So what you can do is you can group your customers, or you will get to know that which customer behave in the similar way. So you can say that customer one, customer three, and customer four, they behave in the similar way because they are giving us the high profit and high revenue margins. You understood? So this is what happens in the case of k nearest neighbor. So k nearest neighbor, what you generally do is you find it out that what I would be able to, find it out who is my nearest neighbor, like what are the similarities in the patterns we have, right? This is what we use for k nearest neighbors. And this you can see that, for example, the algorithm based on the distance based mechanism find it out that how many people, or what type of audience is similar to the outcomes, right? So then moving further here, with the second topic, let's go into detail about what is decision tree all about, right? So far I have touched base on classification based algorithm, right? And I was teaching you different type of classification based algorithm. But since the focus of today's class is decision tree, let's take a deep dive into the decision tree. Okay, so let's get started with decision tree. A decision tree is a graphical representation of all possible solutions to a decision based on a certain condition. What does it mean? It means that it is as simple as that. Imagine that this is a tree, right? So it is like a tree where you have a problem statement that should I accept a job offer or not. Imagine that you want to find it out that should I accept a job offer or not. This is a problem statement which is there in your mind. Now how would you solve this problem statement with the help of a decision tree? First of all, you will start with what we call as a root node. We will start with a root node, starting with, to find it out, what is a salary? Okay, what is a salary I'm getting? So if my salary is equal to or greater than equal to 50,000, I'll go here. If my salary is not greater than equal to 50,000, I will say I will not accept this offer. Okay, now imagine that you say that your salary is greater than 50,000, then you will check another variable here. You will check it out whether I have to commute more than 1 hour. If I have to commute more than 1 hour, I will decline the offer. You're getting my point, right? Then you will, if you don't have to commute more than 1 hour, then you will still consider this option, and then you will check it out. For example, in this case, we are checking it out whether you are getting the free offers also, like coffee or some snacks or other things like that. If yes, then you will accept finally the offer. Otherwise, you will decline the offer. You got my point? This is how our decision tree works. Basically, decision tree will keep on splitting unless and until you are able to find it out your decision. Okay, so here the decision was, shall I accept this or not? Right? So it will keep on splitting unless and until you get your decision whether you do this or not. Like this example which I have explained you. Okay, now, with this, what happens is, like, let me, if I go further and explain you further on this decision tree, let's understand this more importantly, right? Let's understand this one by one. So imagine that this is my data set. Okay. Now, in my data set, you can see that I have various colors given to you. It's like a green color, red color, and a yellow color. I am saying if there is a green color fruit with a diameter of 3, right? And I can say it is a mango. Whereas I'm saying if it is a yellow color and a diameter 3, still will be called as a mango. If it is a red color with one diameter, then it is a grape. And it can be a red color with a diameter of 1, still can be a grape, but even a yellow with a diameter of 3 can be lemon. Now, what is happening in this case is, if you have this type of a data set where you want to predict the label of the fruit, right? You want to predict whether a fruit will be mango, whether a fruit will be lemon, right? Or whether a fruit in this case is mango and lemon or grape. I have to build a classifier, which is a decision tree classifier on the basis of this data set. Imagine this is a problem statement given to you. Now, first of all, what you will do here is you will take this data set, right? You will take this data set and you will start with a root node. Root node, imagine here is like, is my diameter of the fruit greater than equal to 3 or not? Okay, is my diameter of the fruit greater than equal to 3 or not? If it is greater than equal to 3, right? Now, if it is greater than equal to 3, you can see that you have 3 fruits here, 3 rows of the data set here. One is green with 3 mango, yellow with 3 lemon, yellow with 3 mango. And wherever it fails in the condition, you are left with where the diameter is not greater than equal to 3, it is less than equal to 3. Then which are the data set we have? Red 1 grape and red 1 grape. Okay, so I hope you are understanding this, right? How we have starting with the decision tree with the based on one condition here, right? Which is diameter. Now, based upon this, what I will do is I have to split it further. Here in this case, I don't have to split it because I already got the result. So if my diameter is greater than equal to 3, in my data set, if the diameter is not equal to greater than equal to 3, I know it is a grape. right? Whereas if the diameter is greater than equal to 3, then it can be a mango or it can be a lemon. I'm not sure on my decision. So what I will do here is I will split it further. So I have to split this further. Here the splitting is not required, but if I split this further, I may check it out now. Is the color equal to yellow or not? Now, if the color is equal to yellow, then I have two fruit, which is your this row, which is your mango or lemon. And if the color is not equal to yellow, then you will have the another row of the data set, which is which you are left with, right? So this is how you have done this work in the case of your decision tree. Okay, and how you will find it out that which type of the criteria or which type of the algorithm I should, or which type of criteria or variable I should choose here to split the tree is on the basis of Gini index and the information gain, which I will illustrate and show you in the few slides from now. Okay, so I hope with this you understand the how your decision tree works, basically on the basis of the condition. And if you get a pure subset, then no need to split it further. If there is no pure subset, you will keep on splitting unless and until you get a pure subset. Okay. So in this case, what has happened is you got 100% mango. Here you got 50% mango and 50% lemon. Okay. So now this is what I have told you in the previous slide, like how does it work, right? Now, this all depend upon the Gini index basis, right? Now, in the next subsequent slide, let me tell you and explain you about Gini index and information gain. How does it work, right? How does that something works on the basis of your Gini index? So imagine that, like imagine that I have a feature here, is the color green or not, right? Basis of whether the feature, whether you have a color green or not, what would happen here is if the color is green, you will get this row here. If it is not, you will get these two rows here, right? In the next, it may decide on the other basis, right? It can be is the diameter which is greater than equal to 3 or not, and many other things. Okay. Now let's go ahead, the example and the questions which is coming to your mind, which is related to, decision tree terminologies. I'm pretty sure you would have these questions in your mind and you would be thinking that how should I decide that which feature I should use and which feature shouldn't I be using? This is the question which you had. And this is an excellent question for understanding the decision tree. But before I go on to that, I have to tell you about some of the terminologies which we commonly use while we build the decision tree. So first of all, decision tree looks like this type of a tree-based structure. Okay, so every decision tree will have its root node. So root node is where the decision tree will start. So it represents the entire population or sample, and it is further get divided or into two or more homogeneous sets. So as you know that this will be the first feature on the basis of your tree will start. Like tree start with a root, your in this case your decision tree will also start with a root node. Okay, now once you have the root, after that in a tree what happens is you will start getting the branches, right? I hope you understand what is branches. In this case we will keep on splitting unless and until we get a decision whether this will happen or not. So it's like a branches. Okay, then we would also have a parent or a child node. So child node is nothing but when you have a branches, then the branches can also have the outcomes. So in the previous example, like for example, we have whether the diameter is greater than equal to 3 or not. You remember whether the diameter is greater than equal to 3 or not. If it is true, what is happening? If it is a false, what is happening? So this is a child or child node. Basically, this is an intermediate node. This is not the final decision which is being made. So this is called as a parent or the child node. Then we also have other terminology here, which is splitting, which you know that we will keep on splitting unless and until you get a desired node. And finally, the tree end with the leaf node. So always remember one thing, you will start your tree with a root node. Root node is a node with which we will start the decision tree, and you will end your decision as decision tree at a leaf node where you will get a decision that you should do this or not. Okay, and now pruning is the activity where you will cut down the decision tree if it is pruned lot amount of times. I will even explain you this. It is a case of overfitting. You shouldn't build thousand, shouldn't build thousand branches of the tree when it is not even required. So I'll explain you this point. Now let's move further here and let's see this with the help of an example, which was your Gini index and your information gain, right? So this is where you were asking me that which question to ask and when, right? How would you decide that which feature has to be taken first, right? Let's take up an example here, and I would encourage every one of you to hear me really fine here, because this is on the basis how would you decide or how the algorithm decide to break this further. And I'm explaining you with the help of one simplest example, and we will do some maths over it. So imagine that there is a data set where I want to find it out whether I will play the match or not. Okay, there is a cricket match or there is a football match or whatever it is. I want to find it out whether I will play the match or not. Okay, now how do the decision tree look like? Decision tree look like this. If the outlook, if the outlook is humid, if the outlook is humid, and if the outlook is humid and humidity is very high, then I will not play the match. On the other hand, if the outlook is humid and humidity is normal, I may play the match. Okay. If the outlook is absolutely clear, then I will always play. On the other hand, if outlook is windy and the winds are very strong, I may not play the match. On the other hand, if the outlook is windy and the wind are weak, I may play the match. So now what is happening again is that you are not sure how you decided with outlook, how you decided with these nodes here, how you decided with these features here. Let me try to show you this entire data set. So this entire data set look like this. Okay, so this is basically your 14 days data set, and this exactly happens in the case of your classification based algorithm. You will get a data set like this. So you can imagine that you want to find it out. I would like whether I will play or not, right? This is what you want to essentially want to find it out whether I would play or not. On basis of what? On basis of four different variables you have. Four different variables or features in the data set is outlook, temperature, humidity, and wind, right? So now it can be like if the outlook is sunny, temperature is hot, humidity is high, wind is not there, I will not play the match. This is how you will read this one data point, right? Similarly, I have multiple data point. Now I have to decide how can I build a decision tree, and out of these four features, which feature should I use first as my root node, right? So this is what I have to decide, and let's do it accordingly, right? So now what I'll do from here is I will illustrate you what is Gini index, what is information gain, and how does this happens, right? And this is basically used to build your decision tree. So before I make you understand about Gini index or information gain, one thing which you should always remember is to understand the concept of impurity. What is impurity? Impurity is nothing but, you can see there is a basket where you have apples, right? Now, if you have a basket which is of apple and another tray, it is written the label as apple. Now, in this case, you will never make a mistake. You will never make a mistake because here you have an apple, here you have only one label. So everything will be perfect. It will be 100%. Basically, there is no impurity, there is no problem in your data set, right? On the other hand, let me flip the story. In this case, imagine that I have different fruits in the basket, which is like apple, you have a banana, you have a grapes, you have a cherries and many other things, right? And you have many apples, many labels here. In this case, try imagining you have to match each fruit with its label, right? Now, in this case, the impurity cannot be equal to zero. The impurity will not be equal to zero in this case, because what would happen here is that you have a chances of misclassification, right? This is a very important concept, right? when you have perfect thing, the misclassification will not happen. But whereas if you have a multiple labels with multiple fruit, misclassification or impurities will not be equal to 0, right? So this is associated with a term called as entropy. Maybe in your childhood days you have learned about entropy in your chemistry class. In a simple sense, what is entropy? Entropy is a randomness of the space, sample space. Whenever you are not sure on your decision, then entropy will be more. Imagine that I'm giving you the data set where it is like 51% of doing this thing, 49% of not doing this thing. 51% chance that the employee may leave the organization, 49% chance that employee may not leave the organization. So basically you are not sure on your decision. If you are not sure on your decision, then the entropy will be very high. On the other hand, if you are very sure on your decision, then the entropy will be very low. So basically we need that feature which can provide us lowest entropy rather than the highest entropy, to select as that as a good feature. So we generally find it out entropy by the help of this formula. What we simply do is don't get scared with this formula because everything happens automatically in R or Python, right? Imagine, just look at this formula. What is this formula? This formula says that what is the probability that something will happen, multiply by log base 2 probability that something will happen, subtract this with probability that something will not happen, into log base 2 probability that something will not happen. Okay, let's take up an example. Don't worry about it. Let's take up an example that probability that I will win the match, you will apply here, and probability that I will not play the match or win the match, you will apply here, and then you will calculate the entropy. Let's take an example how you can do this in our case. So in our case, let me show you. Yeah, how we will build the decision tree in our case. In our case, you just see here what is happening is that we have 14 instances or 14 rows of the data set where 9 times if you see it, I will play the match and 5 times I will not play the match. Okay, so if you see carefully, there are 9 labels where I'm playing the match and there are 5 labels where I'm not playing the match, right? So first of all, I have to find it out the total entropy. How I will find the total entropy? This is being determined by probability that I will play the match, multiply this with log base power 2 probability that I will play the match. What are the chances that I will play the match? 9 out of 14. All of you will be with me, right? This is 9 out of 14. Multiply with log base 2, 9 out of 14. Subtract this with what is the probability that I will not play the match? 5 out of 14. Multiply this with log base 2, 5 out of 14. So once you calculate this, you will find it out the entropy of this entire system. Entropy of this entire system is 0.94. Okay, so this is the entropy of your entire sample space. This is the first thing. Now, how this entropy will help you in selecting which features you will take or not. So let's go further. So now we will take each feature one by one, whether I should take outlook, whether I should take temperature, whether I should pick up humidity, or whether should I pick up windy, right? Let's go one by one. Now, first I'm plotting for outlook. Imagine for outlook, how many times, so what are the distinct value of outlook? Outlook can be sunny, outlook can be overcast, or outlook can be rainy, right? These are the 3 different combinations you can have for outlook. Now if the outlook is sunny, 2 times I'm playing, 3 times I'm not playing the match. If the outlook is overcast, I'm always playing the match. If the outlook is rainy, 3 times I'm playing, 2 times I'm not playing the match, right? This is how I have bifurcated it. What I will do in the next iteration is, let me find it out the entropy of outlook. Okay, so if we start with outlook, remember this formula, which is probability that I will play, multiply with the probability that I will play, right? And subtract with probability which I will not play, and log base 2 of not playing. So 2 by 5 is the chances that I will play, into log base 2, 2 by 5. This is a subtraction here, right? With I will play and log 3 by 5 I will right? So you will calculate this entropy when outlook is sunny. Yeah. So you got this entropy when the outlook is sunny is 0.971. Accordingly, you will proceed with calculating the entropy when the outlook is overcast. Outlook is overcast, always you are playing, right? If the outlook is overcast every time you are playing, so it means that you will get a probability of zero. If you apply in that formula, you will get zero. And third, what would happen if the outlook is sunny? In that case, you will again multiply and you will put the formula and you will get it out 0.971, right? So you will find it out entropy for each and every distinct combination of your feature. You got my point, right? Outlook being sunny, outlook being overcast, outlook being sunny, overcast, sunny, and rainy. This should be replaced here, right? And then what you will do is you will finally calculate the information gain. Information gain is nothing but what you will do is you will pick it up the chances, you will pick it up the entire chances when you are playing, right? Which is 5 out of 14. You remember 5 out of 14 were the total chances that I will play into if it is sunny plus 4 out of 14 if it is overcast, 5 out of 14 if it is rainy, right? And you will calculate the information from this outlook. And once you calculate the information, you will subtract this information from your total entropy, which I found it out in the last slide, which was 0.94. You will subtract this and you will get the information gain, or this is also called as a information gain from a particular feature. So basically, these type of a calculation, first of all, don't get scared away that you have to do this calculation. But what I'm trying to explain you is this is how your algorithm will work. For each and every feature, it will calculate the information gain from your feature, right? If you have the more information gain, it means that this variable is of very important in predicting that something will happen or not. Okay, so for outlook, I got the information gain as 0.247 with all the calculation. Remember, then we will proceed with wind, if the wind is there or not, right? And then I will proceed with wind and I will calculate the information gain and say information gain I found it out is 0.048, right? Similarly, we will calculate for all the four of them. Let me put it together for all of you. So this is what happens here. Now, if I put in front of all of you, these were the four different variable I have: outlook, temperature, humidity, and wind, right? I am calculating the information gain for each one of them, and the information gain I got for outlook is 0.247. So if the information gain is highest in a particular feature, that feature will become your root node. You got my point. So therefore, we will pick it up outlook as our root node. Similarly, for when the tree gets started later on as a branch node also, your information gain will be calculated, and whichever feature is giving you more information gain, that will be picked up later in the your tree also. So this is how you will build your decision tree, and you will finally get a decision tree like this. Okay. So now what I will do is, like I will quickly show you how do we do the decision tree in your Python. Okay. So I'll show you how do you do this in Python, and then I will summarize for all of you that why decision trees or tree-based algorithms are better than your um other algorithm. Okay. So how do you choose? Basically, that which algorithm you will select and when. Okay, so I'll describe you this, but before, let's jump on to Python and go there. So what I have done here is, like, I had built the decision tree in front, already. So quickly, I will walk you through the commands. Okay. So what happens here is that in Python, as you would be well versed with this, that we generally import packages in Python. So I'm importing NumPy, I'm importing Matplotlib for plotting the chart. I'm importing various packages from your sklearn, which is for machine learning purposes, right? So I am importing your label encoder, your decision tree classifier, classification report, and I also I'm importing your tree. right? So we have all this which I am importing, right? After I import, what I will do is I'm reading my data set. So I'm showing you this with the help of our iris data set, which is one of the very popular data set for building the decision tree, right? For any particular source. So imagine that this is my data set, and I'm just showing you 6 rows of the data set where, like, I want to find it out whether a particular flower species will be Setosa, versicolor, or virginica. I have three different flowers which I want to predict, and on the basis of sepal length, petal length, sepal width, and petal width. So basically, I have different dimensions of flowers length and width, and based on that, I want to find it out whether the particular species will be Setosa, versicolor, or virginica. You got my point, right? So this is a data set. So what I will do is, as you know, with every machine learning data set, we play with the data set. So I'm checking the information here, like what type of the data type it is. So sepal length, it is a float, petal length, it is a float, and species is a object. Why object? Because this is a categorical column. So after this, I'm also checking whether there is any null value present in the data set or not, because if there is any null value, then we have to get rid of that null value, or we have to replace that null value with some imputed value, right? This is what I'm checking here. Once I do that, I'm also plotting this because we usually do visualization, right, to understand the data set better. So what I'm doing here with the help of SNS, which is your SNS.pair plot, I'm plotting all the possible plots. So basically, sepal length with sepal width, what type of the combination look like. So Setosa, versicolor, and virginica, there are three different species you can see in the data set. And this is what I'm getting a trend between your sepal length and sepal width. Similarly, this is basically from sepal width to petal length, right? So this is how I'm understanding the patterns, or I'm understanding the relationship between the variables in the data set. So this is what I'm understanding here. I am also checking whether there is a correlation or not. Higher the shade, it means there will be a strong correlation. So all of these things is being done as a part of exploratory data analysis before even you start your machine learning model, right? Once you do this, after that, what I have to do is, after that, what I'm trying to do is, I am taking your species column, what I want to predict, as my target variable, which is your dependent variable. And so this is the dependent variable, and with the help of what I want to predict will be my independent variable. So I'm calling X all my independent variable, and I'm calling target as my dependent variable. Once I do this, then you will also think about it that the variable which I want to predict is the flower species, right? But I want to convert this into 0 and 1 class, 0, 1, 2 class, because your computer cannot understand text, right? Computer can only understand the numbers. So what I'm doing here is I'm changing it to the class, right? So what I'm trying to do here is, I'm saying wherever it is Setosa, it will become 0. Wherever it is Virginica, it will become 1, and it is versicolor as a third category, it will become 2. So now imagine my data set, my label to predict becomes 0, 1, or 2, instead of 3 flower, which was Setosa, versicolor, and Virginica. This is what I am doing with the encoder here. Once I convert this and this become my target, what I will do is, as I told you, that I will split this data set into training and test data set. So basically 80% of the data is going into the training data set, and remaining 20% I'm taking as a test data set. Okay. Now I will call decision tree classifier. Like, I want to make a decision tree, and I want to fit this on my training data set and the test data set. And I will start building the decision tree, and with the help of, so here is when I have created the decision tree, and here is when I'm checking the prediction, how accurate my decision tree is. So I got my precision, which is good. I got my recall, I got my F1 score, and I also get the support, right? So all these matrices are being used to calculate your how accurate your predictions are. So higher the precision, better the results would be, right? And finally, I'm showing to you that how does the tree look like. So I had tried to plot this decision tree in front of you. So basically it starts with petal length, and you can see the Gini index coming up here, or the information gain, which is information gain and Gini index are reciprocal to each other. If you want to use information gain, you will get that score. If you don't want to use information gain, you will get Gini index. So they are both reciprocal of each other. It is one and the same thing. You use Gini index or you use information gain. They are the two different metrics to build your decision tree. So you can see that based on a petal length, the tree gets splitted like this. Then based on the petal length of different dimensions, your tree further split, then it further split, then it further split, and finally you get to know that whether the particular species will be versicolor or virginica. Okay, so this is how your entire decision tree is built in Python. Okay, so this is how it's so simple. I know it takes time to build this thing, but once you are a good data scientist and you understand all these things, it is very simple to build all these things very easily in Python or R, right? So now, finally, going back, how would you decide? How would you decide that which algorithm, which algorithm will be taken when? So what happens is this is on the basis of scikit-learn. So it starts something like this. Okay, so it is on the basis of like this, that first of all you see here that um, whether how many samples you have, how many data points you have in a data set, right? If you have more than 50 samples, then you will go here. If you have less than 50 data point, then you will go here. So you will get more data set, right? So if you have more data, if you have greater than 50 data point, then you will go further, you split of your data set. If it is not, then you just the kind advice it, get more data set. Okay, so then you will decide that what you want to predict. If you have a labeled data set, then you will go here, right, and do clustering. If you don't have the labeled data set, then you will see whether you want to predict a quantity. If yes, you will go in regression. If you want to predict, if you just want to do exploratory analysis, you can do dimensional reduction. If you have a labeled data set, for classification, you can do all this classification. So basically, this is a cheat sheet which we generally use to decide that what we have to do with the data set and when. Okay, so I'll stop here, and I hope this was informative for all of you. I hope you learned something new today. So thank you once again, everyone, for your this thing session, and I hope you found the session helpful, useful. Bye bye.